Hello everyone, my name is Li Hao. Today we are going to look at how we can visualize sorting algorithms in Svelte. So if you haven't seen this before, this is one of those YouTube videos that visualizes how sorting algorithm works. As you can see here, there's a list of bars on the screen with different heights, and as the sorting algorithm goes, the height, the order of the bars will be rearranged, and slowly, as you can see, assorted bars will emerge. So that in the screen you see red and green color. That would be what the algorithm is looking at, which bar the algorithm is looking at. Right. So we are trying to see whether we can do this in Svelte, this kind of visualization. Right. So let's pause this and head over to the REPL. Here I have the basic REPL, which I'm gonna remove everything as usual. Let's see. Let me zoom this in a bit and maximize it. There we go. So the first thing is we are gonna create a random array. So called random array equals to get random array. We're going to have this function. This function will generate a random array as it suggests. Right now, let's return an empty array. And what we're going to do next is that we are going to use each block to loop it. So random array as item. And for each of them, I'm going to have a div. So in the div, I am going to have a style. Say background equals to white, right? The bar is white color. So this will be each of the div will be for one bar. So the array itself probably will have the value of the array probably will be the height. So the height will be the item px. Width I'm going to be arbitrary here, probably 3 pixels. Display, I'm going to use inline block so that it does not take on the full width. And margin, I am going to give it 1 pixels left, right. So you will see like the bars will be slightly apart rather than close to each other, right? That will give us a little bit breathing space in between bars so we can see them better. But here, this is the container. Okay, so probably you're gonna have a style. The container will be position relative. We'll see that later. And then the height will be 100 pixels times width will be also 100 pixels. And I'm probably gonna we'll add a style for the body to be black color. Right, so it's full black, just like this one. And the bars are gonna be white in color. So the next thing is that we're going to generate this random array. We have 100 to 100 over here. So probably we're going to have 3 pixels of the width, 1 pixels on left and right margin. So that will be 5 in total. So let's have maybe 20 bars, right? So for let I equals 0, I less than 20. And then because the height is 100, for simplicity, we're also gonna have generate a random height that is like say roughly 100. So okay, gonna be result and return result over here instead. And result dot push math dot random times 100. Immediately you can see 100 bars over here. 20 bars over here. Height that is random from 0 to 100, a random value. It's not sorted, it's random. And the next thing we're going to do is to sort them, right? So let's start with a basic sorting algorithm. So I can't remember what's the name of this algorithm, but I'm gonna write it out, and probably those who know what this algorithm is can tell me the name, right? So I have I to, and I have j starting from I all the way to this is -1, right? So I'm going to loop through the ith position and also loop through a jth position from the I onwards and try to find an element that is less than I, right? So like if the position, so I'm trying to look through all the elements that is beyond I. If it's greater than what we have, we're gonna swap it out, right? So we are going to swap I and j if random array I is greater than random array j. Let's swap them out. And this swap function, I'm going to implement it here. I, j, gonna be equals to random array I. Okay. So as soon as we call this sort function, you'll see that it's being sorted, right? Perfect. But now it's not. And so what we're gonna do here is that we are going to use onMount and call and only start sorting when it's mounted, right? So onMount. Set timeout. And I'm gonna sort. Right, so within, say for 500. So half a second, you will see that it's not sorted, becomes sorted. Right. So this is not that nice, right? It's not animated. So one way you can do is you can use flip animation from Svelte. Import flip from Svelte animate. And if you apply this flip, so what this flip does is that when you apply it to an element, and when that element when that element changes the position, it will try to animate that element into the target position. So that's how you write it. Animate flip. So over here it says that if you want to use animate flip, you have to use a key H block, meaning you have to have a key over here. So by default, the key of an H block in Svelte is the index. This means that when there's a change in the array, in this case the random array, Svelte will loop through each of the elements based on the index and match it with the data in the array for the given index. If the data at that index has changed, Svelte will update the element according to the data. But if you provide a custom key, when there's a change in the array, Svelte will loop through each of the elements, try to match the key used to render the element with the key of the data in the array. So if the position of the element of the same key is different to the position of the data in the array, Svelte knows that we have shifted the item around and will shift the element to the new position. And if the key is no longer exists in the array, Svelte will remove the element from the DOM. So here, what I'm going to use as the key would be the item, right? As you can see, once we have animate flip, let's try to run that again. Once you have animate flip, when it changes the value, all the elements will be animate to their target position, right? See that again. It looks perfect, right? Except that if we want to visualize sorting, we want to only swap items by item. Every time when we do a swap, I want to wait for a while before we do the next swap. Because when we do a sort function, we do it synchronously. We swap all the positions, and then we visualize it, right? And that way you only will see the beginning of the random array and then the sorted array. You don't see anything in between. What we are trying to do here is that we want, on every time we do a swap, we want to pause for a while, and then we visualize it, and then we come back again, and then we do the next swap, right? So there's multiple ways of doing this. One way I'm trying to explore today is to use a generator function. So for those who don't know generator function is a function that when you declare as a star, and this function allows you to yield at any point of time. When you yield, you'll pause the execution of the function, and it will continue. It will pick it up from where it yielded if you call that function again. Not exactly the function itself, but we shall see, right? So what happens if you call sort, right? What happens is that it will return something called we will return an object, sorter. I call it sorter. So this object has two methods. One is called next, and one is called done. So sorter is something like this. Done is a boolean. So if it's done, meaning it has finished the execution of this function, done will be true. And to actually start this, you will just keep calling next, right? You call next, it will do something, and then you will yield at where it yields, and then you return immediately. And if you want to do it again, you call next again. So you keep calling next until done is true, right? So this way we can control when to actually do the next, when to actually do like one swapping, and then we pause, wait for 500 milliseconds, and then we call next again, and then we pause again, we call next, pause, call next, we pause, next, pause, until the done is true. And then that's when we know that the array is sorted, and that's when we will end, right? So how I'm going to use this sorter is that I am going to we're going to do it over here first. I'm going to have this sorter function. And instead of timeout, I can do set interval. I'm going to add the interval ID. And I'm going to call sorter.next. Right. And if sorter.done, sorry. I think I'm wrong here. So next, it only have next, but next will return an object called done and the value. Right. So over here I can do is done. And so I keep calling next and then if done is true, I'll clear interval ID. Right, so you can see here, we're gonna keep swapping, wait for 500 milliseconds, and we do the next swap. 500 milliseconds later, we swap again. So how it goes is that we will call next, we'll do one swap, and then we yield, and we'll come back over here. And because it's not done, we are going to let this interval keep going. But once it's done, so keep going as in the next callback of this will call next again, and we'll continue pick up from where we stop, and we'll do the next loop. And then if we encounter this yield again, we will stop, come back from here, and then if it's not done yet, we will not do anything, and then we'll set a next interval. We'll wait for the next interval, and in the meantime, Svelte will paint, because Svelte notices that random array has changes in between. It will have time to actually paint it out, render the output. So when you yield, you actually when you yield, and over here you are done with this frame, right? Because you return from here, and then you if it's not done, you don't clear interval, and then you are done with the callback over here. When you are done with the callback, you actually run nothing on the main thread anymore, and that's where the browser can schedule like the next frame to paint, and Svelte will pick, and Svelte in that next frame, Svelte notices that random array has changed. You're gonna update the DOM, and that's when you see that there's an animation in the DOM. But when that after that, because we are using set interval, probably 500 milliseconds later, the interval is timeout. It's time to call the next callback of this interval again. That's when we call sorted next to pick up from where we stop in that function, which probably will start from here again, and then you will continue with the loop. And once it encounter a yield again, you will pause, it will come back, and then over here you continue from here. You will notice that done is not true. You will continue the call. You will skip this if check, and then you will finish with this callback, and then give back the control to the main thread. And then because and then the browser schedules the next frame, and because the random array has changed, Svelte will render that updates that change on the screen, and as the next interval times out after 500 milliseconds, then we'll come back and continue this whole thing again and again. Right, so let's take a look again. Now it's sorted nicely. Right, now we see the animation. So one thing that we haven't seen here is that the two elements that is going to be changing. In this example, we're going to see red bars on the elements that is actually being looked at or being swapped, right? We can do that by having two variables, right? Because we are going to swap I and j, so we're going to have two variables called I and j. And so if it's, and I will be this I, and j will be the j that we are swapping at, right? And once we are done with it, we can reset I and j back to undefined, right? And with the I and j, we can actually use it over here. We can compare the index. So if index equals I or index equals j, gonna be red color, or else will be white color, right? So you can see as we are comparing these two elements, the two bars will be in red color, and yeah, the one that is not moving will be in white. Right, so basically that's about it. This visualization, I would say it's almost perfect. There's a few things that we can try and explore, which is you can have a custom easing function. If you're familiar with transition, it's the same thing. You can add easing to flip animation as well. So for example, you can have say sign in out from Svelte easing, and you can pass that in for over here as a custom easing function. And same thing goes for duration and delay if you want, right? So say I want the duration to be 200 milliseconds, then you will move faster. Right, I'm not sure you can tell the difference. Probably let's make it slower so that we can notice. right? So this is basically is how it's become slower. And because we update the I and j way much faster than the animation, because we update I and j every intervals, right? And that interval is 500 milliseconds. That's why now it's a bit weird looking. So probably we're gonna set it back to say 500. Just nice as the interval ends, and then we're gonna sort the next thing, right? So that is, sorry, probably do a 200. We can move faster, and then we have a breathing time, right? So that is how you use animate flip to do a visualization of a sorting algorithm. Before we end, let me paste a code that I've written earlier. Quick sort. It's the same thing. We are still using a generator function. Over here, the difference is that a few things I want to point out is that you can use something like a yield star, which means that sort itself or split itself is a generator function, and you don't want to, if you want to yield the whole thing, you want to yield whatever is, you want to yield whenever the inner generator function is yielding, because in this split function you are yielding over here, and you want to yield as, like, you want to delegate that yield to this generator function, you want to yield at the same time, and probably you can use a yield star, right? So every time when the split is yielding, this sort function is yielding as well, or else you will just yield once by calling it, and when it yields, you are actually not doing anything. What you yield is actually the generator function, right? So I can change this sorting algorithm to become quick sort, and you can see the difference of quick sort versus the sorting algorithm I just written. Sorry, I think previously I wrote shuffle array instead of random array, so probably I'm gonna replace that. My bad, inconsistent naming. Random array. Yep, so you can see it's doing a different comparison and different swapping now. There's a pivot. That's how quicksort works. If you want to learn more about quicksort, I can send you a link down the description, a better tutorial teaching you how to do quicksort. Yeah, so over here, that's how quicksort works. We can take a look at it again. And that's all. This is how you visualize sorting algorithms using animate flip in Svelte. Have a nice day. So thank you for staying till the end. If you like the video, give me a thumbs up. If you want to stay notified with my next video, please hit the subscribe button down below. As always, stay safe and well. See you next time.